Hey everyone, I'm David Room. Tonight we're going to be doing some more 3D modeling with Python, working on some high detail spacecraft stuff. Um, should be a pretty chill stream tonight. I'm mainly focusing on doing some refactoring and fixing up some models or designs, I guess. I don't know what the best word to call them is, but ship um, ship projects that I've had for a couple years, and I've kind of revised as I've developed these different methods for programmatic modeling. And the past few streams that I've done, I've been working on a larger ship, and now I'm taking some of those techniques back to some of the smaller ships, and made some good headway on this over the weekend, and anxious to kind of get back into it here with anyone who wants to watch and uh, just see what we can do. I've said before, the reason I do these streams is because I think it's kind of fun to try to push myself to, uh, code live and in front of people. It's a good way for me to focus. And I hope that people who watch get something out of it in terms of learning more about Python or thinking about how you might, work on a project like this by yourself. Um, and I'd invite people who are watching to work on your own project or something while you're watching. I know I like to listen to live streams when I am working on my projects, and it gives me a lot of encouragement to feel like there are other creative people out there who are working on things. So, and I'd love to hear about what you're working on, or if you have any questions about Python or 3D modeling or what I'm doing. I'll try to explain kind of what I'm doing tonight. I'm probably not going to listen to music. I just kind of not feeling it tonight, so it's going to be just more chill, probably keyboard sounds, and I'll try to explain uh, some of the process that I'm implementing. But let's um, let's get into it here. So just a little review of what we've been doing. So for uh, the month of July, and actually most of June, I've been kind of focusing on this high detail pipeline. So just to back up a little bit for people who might be new. Um, so I'm developing a retro space combat game, and all of the models, ship models, and different things for that game I'm creating with Python. But I also have a sort of a separate or additional workflow where I can take these sort of low poly models that I'm creating for this game and then add lots more details and greebling and materials, procedural materials and things, and be able to render them in Blender. And the goal there is to kind of approach something like um, professional TV or movie quality assets. I know it's probably going to take me a long time to get there, but that's kind of the end goal. And it's been a fun project to work on over a period of a couple of years. So I've been working on this high detail aspect of this project, and the was working on this larger frigate, kind of updating some of the functionality for dividing things into panels and adding different greebles, trying to build functionality here that lets me build designs that don't look random, like just a bunch of random detail added, but kind of look like things that make sense, details that go around other components in a way that kind of makes things seem cohesive. The last live stream I did, we finally got this guy into Blender and started adding materials and seeing how the sort of more realistic materials look with some of the greebling, and I think it's a pretty good start. Over this weekend, I got some more of my ships up and running again in the high detail pipeline. I always refactor things and then don't fix everything. So sometimes it takes a little bit of work. So we were working on this big ship, the Ashinoko, but then I got the Sayota and the Needle. Sayota, which is a corvette, and the Needle, which is a little fighter, going. And now I'm working on a ship called it's hard to pronounce because it's French, but the word means shark. It's called the Requin. And this ship is actually the first ship that I designed for the game, and it's like one of the first things I tried to build with this programmatic 3D modeling workflow that I have. So it's kind of special to me. People always say that it reminds them of the Kilrathi ships from Wing Commander, and I'm not sure that was a conscious inspiration, but I can see it. You'll get to see it a little bit better here in just a sec. So basically, I'll actually just run this, and I'll run this, and we'll take a look at it. So basically, what I'm doing now is kind of updating some of the different details and components of the ship for this new approach that I have. I'll explain that here in just a second. And I'm also going to be doing some refactoring tonight. So just some kind of chill rewriting type work. I'm going to turn panel diffs off so this actually runs decently fast. I'll explain what that is in just a second too. So yeah, so this is the basic design, and this is what the low detail version of it basically looks like. So this is more or less what's in the game, except there are some extra subdivisions on different components here. And then what happens is this sort of like base model, and it's not a single mesh, it's a bunch of components, gets modified with all these different functions that create greebles and additional details. But part of the problem here is that that I've kind of changed the workflow. So when I originally was doing this high detail workflow, my low detail models for my game project were somewhat lower detail. So you can see here there's various like hard points and sensors and thrusters and antennas and things even in the low detail model that originally weren't there. And that's something that I added at the beginning of this year, and it was one of the best decisions that I made because it kind of unifies the low and high detail models a little bit more. And what you can see going on here in this high detail model is that there are some greebles, and some of these I want to keep, but there are other ones like this thing right here and this thing right here and these things on the side that are extra components that are left over from when I first added these components to the high detail versions, and those need to go. So that's one thing that we got to do tonight is get rid of those components and make sure that the correct set of components is being used for panel cuts and different things. So that will be something that we'll do. And I also just want to do a little refactoring and cleaning up. So, and what I was actually working on the other day, which is why I had a screenshot in Blender of this particular part of the ship, is that so I have these functions that basically let you take a component. I'll just gotta shift this a little bit so I can grab it. Let's see here. Actually, maybe I'll just grab this here. So like this wing that, you know, you have this underlying model, and I have a function by which I can slice that wing up and like add all of these little panels and details. But there are certain limitations to how that works, and one of the limitations was that paneling, like turn a face into a panel, didn't work with meshes that have concave pieces. And it still doesn't in certain circumstances, but I added the capability for it to work properly when it's a mesh that is completely flat and has a couple other properties. So you can see here, you can see how this chamfered panel kind of fits properly on the wing. So that's what I was working on last night. So yeah, I mean, looking more closely at it, we got to get rid of this piece and not use it for these cutouts. And then we want these pieces to engage with the cutouts. We also have to shift them to compensate for the panel thickness. And then we also need to make higher detail versions of some of these components. So these guys are sensors, and you can see they're just the same sort of low poly thing that is in the original low poly model, and we want to give these a lot more detail. I might keep the hexagonal shape of the shields here, but you can always add little details, additional beveling, things like that. So we might work on some of that tonight too. We'll see how late I want to go. I think it's going to be a pretty chill stream though, so depending on how I'm feeling, I might just let it go, because usually this time of night I stay up late working on this, and I've got my coffee in me. I'm feeling pretty alert, ready to go. Had a kind of a nice day at my job today that wasn't too stressful, so I'm not fried out on programming, so we're going to just see how much we can get done. So, and I see too, I thought I disabled panel cuts, but it looks like these guys are cutting. So another thing about this model is that the way it kind of works the original way I implemented this, where to kind of get a sort of unified feeling between the panels and the components, I have the components act as cutters to kind of cut these holes in the panels. My newer approach kind of doesn't use mesh booleans for a lot of different reasons, but this one does, and I was fiddling around with that too. The problem with booleans is that they're slow and they're also really fiddly. It's very easy to get into these weird situations where they don't work either at all or don't do what you think they're going to do, and it's and they're just kind of frustrating. Also, so I'm developing on Mac now, and the library that I'm using is using OpenSCAD for the mesh booleans, and I think part of the problem might be that OpenSCAD is using a like an Intel x64 binary, so it's kind of running slower on Apple Silicon than it should, because it's way faster to do this stuff on my desktop machine, which is a Ryzen CPU. So yeah, so let's get into it. And I've got to do some just other basic things too, like I used to have all of the high detail ships in one module, and now I'm kind of splitting them up, so we're going to just be moving some code around too as well. So let's get into it. What is doing that cutting? Okay. Yeah, right here. So I can disable this. So I use this sort of, a lot of this code, there's wrappers around a library called TriMesh, but I also use some of my own data structures for things just because it's fun to implement things the way that you want. And I have this data structure called parts, which is basically just a dictionary of record types that each hold a mesh or different objects and like a transformation and a description of how it fits in the hierarchy. So you'll see a lot of these operations that operate on parts, and I can do different things with parts. I can process them different ways, and then I can actually very quickly load them into Blender for interactively visualizing them. So something that's sort of different about my approach versus other stuff that you might see on YouTube or in other tutorials is a lot of people will like use things like geometry nodes, or they will actually write code that they run inside Blender through add-ons or different things. And in my process, I'm not really doing any mesh processing with Blender. Blender is kind of for rendering. So I'm building everything just in Python code, and I could export it hypothetically to different places. But then I'm sort of building this scene with my own representation, then starting a script in Blender that just loads that scene in. So that's kind of how things are getting into Blender. And I just got going with Blender 4.2, so I'm still working through some of that, but if we can, we also might try to get this ship with the materials and stuff on it into into Blender for rendering. So right now I don't have any lights or materials or anything set up. It's just looking at the meshes, but we might try to get it into rendering tonight too, depending on how far we get. Okay, so let's take a look at this. I think this is it right here. So I'm just gonna comment this out, see if that gets rid of those offending parts. Yeah, looks like it. And then we're gonna have to put the other greebles that we have now basically into the same kind of operation and use those instead. Yeah, okay, that looks better. Something that I kind of was working on at the beginning of the year is, you know, I want my designs, my spacecraft designs, to kind of make sense. So instead of just having these different components placed willy-nilly, I spent some time and figured out, you know, where they would actually go to be useful on the ship. So you're seeing some of that here, kind of versus the old look. And I think let me actually just see if I can find a picture of like what this ship used to look like. So, you know, here's like the new design with the new sensor placements kind of in progress. And let's see here. The old design looked like this. So I originally had these sort of double radiators, which doesn't really make sense because you don't want the radiators to radiate into each other. Yeah. Also, when I was first doing a lot of this work, I was using materials that have a lot of panel lines even in them. I was thinking I could probably do more with procedural materials than I could. Now I'm kind of leaning towards doing more with actual geometry. So that's kind of another difference in approach here. Okay, so that's looking good. So I'm gonna just get rid of all this code, and then we will yeah, okay, we can work on, I think. So another thing that I started doing that's really helpful is kind of pulling more of these different things into functions. So I'm going to do some of that as well. Actually, pull this a little bit closer to me here. And okay. So yeah, let's just bring some of this stuff out. So, and I'm just gonna look for reference at how I did it. It always changes, and yeah. So I have these functions that basically take the full set of parts and then return a new set of parts that return a new set of parts that includes the details that we're adding. And then those new parts can get sort of merged in at different points. So here's kind of what the outline looks like for the Ashinoko. So you have kind of like the main low detail and high detail versions, and then you have all of these private functions for doing different things. It's a lot of code, but it's fun to do things this way, and it's also really powerful because when you want to start tweaking things, you can do it without having to redo a whole bunch of manual modeling work. Okay, so actually we'll do this over here. Yeah, okay, cool. Okay, yeah. And this was, yeah, this is the adding additional detail to the thrusters. So we'll just quick make another function for that so we can kind of see. Later I'll rewrite these to not mutate things. But for now, and let's see here. And this, I think, this one's gonna be a little bit easier to rewrite as a functional thing. We can okay. I think we'll save some of the rest of those functions for a little bit later. Let's just see if this looks like what we expect it to look like here. Okay, so, oh. Oh, okay, so that's what's going on. Actually, yeah, I think. Just some little issues with parents and things. There we go. Okay, so that's working. So at this point in the code where we're skipping out, we've got all of our low detail stuff. We've got the panels on the fuselage. And at this point, we'd be ready to do some cutting. Some cutting of those panels. So let's just do that. Let's just try that and see what happens. And then, oh yeah, and we need to tweak those too. We need to tweak the positions of all of the components outward a little bit so that they sit out correctly. Because, yeah, so I can show you. So like without these panels, we have a proper proper alignment of everything. Like this isn't, that isn't intersecting anything, you know. Okay. So need to have my polyscope part sphere actually do the multiple meshes so I don't have to fire up Blender every time, but that's okay. So when we do this operation with, we have this adjust for panel thickness thing. So so this is basically a list of prefixes and a list of exact matches that we want to adjust. And the panel thickness should be, okay, that's something, I want to make that a constant. I've adopted better practices as far as making some of these things constants. Yeah, so this should be panel thick. My guess is the drive panels are gonna use that same thing. Okay, so now we can do this adjustment. And before we do it, I'm just gonna look at the names of the components, and we can have that open while we do the adjusting. So let's see here. These start with thruster, that starts with sensor. Hard points we could do to sensor, shield. I think everything kind of makes sense here. So thrust ring, oh that's interesting. So we have thruster and thrust ring. So sensor, shield, hard point, we don't need this guy, we don't need that, thruster and thrust ring. And the antennas I don't think we need to adjust, and this stuff we don't need to adjust. Shield, small. Okay, cool. All right, let's see if that works. Oops. Oh. One thing I don't like about Python is how the curly braces, you can make either a dict or a set, but just a purely empty set of curly braces as a dict. It's confusing. Oh, interesting. I wonder if I have, maybe it looks like I have some Euler angles here that I need to convert to rotation matrices. So let's try to do that. Let's do that first. So find rotation matrix. That's it. Find rotation matrix. Okay, let's see if that solves that problem. Oh. What's going on here? Part.trans is none. Oh, is not none. Jeez. Okay. Yeah, so basically in my parts format, the parts can have different ways of expressing the way the rotation is represented, but I guess this function was expecting rotation matrices, and there's probably a cleaner way to do that, but I just didn't feel like digging with that right now, so it's just gonna expect that they are rotation matrices. Okay, and it'll convert them now. So let's just make a note of that. Okay, so and the adjustment was working correctly, if you saw. So all of those greebles were shifted out, so they're sticking out properly through the fuselage paneling. Okay, so let's fix some of those greebles up too. So first of all, I want to go back to having the shields be hexagonal, the shield generators be hexagonal shaped. So we're gonna fix that quick before we do any other stuff. And actually, you know what? As long as we are yeah, we'll keep this here for now. Yeah, okay. So what I want to do is I need to merge these two files together so that everything is all in one piece. But let's just take a look at the shields here. And whoops. So we want to keep, we're going to keep 6 subdivisions for the ring, but let's see here. Ring mesh. Here's my ring mesh. And So this is the low detail case here, just a simple 6-sided cylinder with an offset. So if LOD is greater than or equal to 0. Otherwise, if it's a high detail thing, I'm going to actually copy some of this stuff here from the Ashinoko just for now. Yeah, so basically we just want to make a sort of slightly pyramidal cylindrical shape with some extra bevels on it. And actually, bring this into here. And this will really start to sell this ship as kind of like a higher detail thing when you start adding some of these details. So I'm anxious to see what it looks like. So it's going to be small rad, and then the bevel is going to be probably like half that size here. Like Y extra. And then this bevel amount is not going to be so big. So, and I'm going to not do 2, I'm just going to do 1. So the radius of this guy is 0.45 meters. So like what would be a good bevel? Maybe like 10 centimeters, 7.5. Okay, and then let's see here, X90. I think faces. Yeah, actually we can bring this guy back out. Okay. Let's see how this looks. Okay. Yep. Sorry, I just saw your comment now, Doug. Yeah, re-greeblification. So we're making some higher detail greebles here for the ship. That looks pretty good. Could probably come out a little bit higher now, but that's kind of what I'm picturing. I like seeing the hexagonal shape, and we could do something similar too for these. Why don't we do that actually, as long as the code is kind of fresh here. So let's see here. So these are the thrusters. Thrust mesh. Oh, nice. Do I have this in a separate function? Oh, yeah. Cool. Cool. Okay, so This is nice because we can kind of share some of this logic. Share some of this logic here. So this bevel y scale function, it kind of figures out if you have a shape that you're building up from ribs that are of a certain radius, it figures out how to add ribs in between them that accomplish a nice perfect bevel according to the radius of the shape, because there's different ways that you can measure that. There's probably a better abstraction for this somehow, but I haven't figured that out yet. So the y scale, and for whatever reason I'm doing these as kind of like double-sided, exactly the same thickness on either side, and the radius is thick. Why do I call this RCS rad? That should just be RCS bev and RCS thick, right? Yeah. It's rad. Whoops. So in PyCharm, if you hit Shift F6, you can quickly refactor things. Okay, so, and then the bevel, let's do a little tighter bevel on this one. So we'll do like just do a 1.5 centimeter bevel, and we'll slope the top in a little bit more for variety. And let's see, my scale, and then this is just res. Okay, so all right, and let's see how this looks. Well, need to rotate those. But do they look like I was expecting? Yeah. Yeah, they do. I think those are wrong, because I think they were supposed to go the other way. Let's just get rid of this stuff quick so we can compare with the low detail version. Yeah. Yep. So these are facing the wrong direction, so I just have to just flip them around. Yeah, that's looking pretty sweet. Okay. This is good because I've had all this code that has these placeholder arguments for LOD, and wasn't using it for anything, so it's feeling good to actually start. And the next thing is going to be these little sensors. So let's fix those too. We can also add a little bevel on these hard points and more subdivisions on the antennas and stuff too. But yeah, let's fix those forward-facing sensors. And I'm just going to drop some to-dos in here for additional details. We won't work on that right now, but that would be a nice thing to do in the future. Shit, it's right in here. Okay. There's additional details on these thrusters for the Ashnoko, and I got to figure out how to organize things better. Like if I want to have sort of a master, you know, here's a module of all the different thruster types, if I want to organize them by potential manufacturer or style or what, because I'm trying to have a few different styles of these things so that not all the ships look alike. There's kind of like an older style of thruster that kind of looks more like a RCS, like a RCS quad, and then there's this newer style that's more triangular. It's all kind of magic how things work in my setting, but there's a couple of different thoughts about how those things would work. Okay, so yeah, let's try to add some extra to that to those sensors. So let's see, like sensor double and sensor lens long. Let's start with sensor lens long. So okay, cool. So subs is a parameter, so I should subs is 4, so this is good. So if 0 is 4, else subs equals 12. And then, you know, we could add additional stuff here. Yeah, and then this is another thing that we've got to fix here. So I don't know if in the game it really needs auto smooth angle of 45, but for the high detail versions, usually we want like 30. And let me just see where else we have auto smooth angle of 45. That's it. Okay, I suppose it's really just those sensors that were kind of showing up that way. Yeah, there we go. Now, this looks cheesy. So to me, I think what we want to do is for the high detail version, they need to be a little bit smaller. Like there's some mathematical formula by which, you know, there's like what circles look like perceptually. Like this looks like a smaller radius than this because it has fewer points, even though it is actually the same size. So let's just say if, let's see, are these, actually I should have paid attention. I gotta see what coordinate system I need to scale in. Okay, so if see, okay, yeah, it is y. And let's see what looks good here. So this is the nice thing about having blenders. You can kind of test things. So let's see here. So let's just see if we adjust the x and z to like 0.8. Does that kind of look like what we want? I thought it was around 0.8. And actually, here's what I'm going to do. I'm going to grab the other ship and set it right above it so we can see where are we at. 38. Let's just make this even. Now we can kind of compare and see how things look. I really like this front view. It's fun to see things, and it really starts looking real. You start seeing all the panel lines and stuff. I think that looks pretty good. And what is going on here? Are these actually that's interesting that they're Z 0.05, so they're slightly raised up. I didn't remember that I did that, but it looks, oh, oh, I bet, yeah, I bet that's the offset. Yeah, I don't want to include those in that thing, but I would say 0.8 looks like the right scale here. We can definitely add more detail here as well, but we can start there. So what do we want to do? We want to not include these in the this. Oh, shucks. X is less than 2. So we want like 0 and 1, but not. Let's see. Yeah. Yep, that looks like it, and that looks great. Nice. I'm feeling good about this. Yeah, because that is, yeah, that one is 0. That one is 1. Okay, cool. This This is all just feeling so much more solid than it did. When I was first putting this together a couple of years ago. It's really fun. It's really fun to see it come together. Even just having different shapes for these that aren't simple beveled cylinders really helped. You know what? Okay, one thing at a time. We gotta do the scaling on these guys. Long. We're gonna just scale this. Actually, what? We gotta see what coordinate system this is in. With the panel cutting disabled, though, this runs really fast, so it's easy to see. Why am I doing these rotations if... Why am I doing these rotations if it's already in the right... Oh. Oh, I know what this was. This was when these used to be 5-sided. So I was realigning them so that the points were flipping the right direction. But we don't need that anymore. Okay, so scale this down in XY. So if LOD is less than 0, scale mesh 3 of 0.8, 1.8, and don't mesh long. Now it's saying that this isn't used. Don't mesh long. Oh. I just have to say and right away, let's hit that hard point. So if LOD is greater than or equal to 0, then we're going to do this, and we could do fancier stuff later too. Oh yeah, we can actually do chamfer here too. So chamfer is none, and else let's try 10 centimeters and 2 centimeters. 0 and equals u dot about polygon chord and let's just make sure that this is what we expect. Nope, nope. Too much. Oh, we only have an inside of 0.15. So this has to be might not be possible to find something that works quite with this, just the way it works, but we can keep going smaller here. Nope. What gives? Gets. Oh, yeah, it's just. Oh, that's right. Is it that it needs to be bigger? Whoops. Yeah, I think that's it actually. It needs to be, the bevel needs to be bigger. Because we're insetting by that much. Yeah, it actually needs to be bigger. It needs to be like that much. There we go. Yeah. Okay. Low detail. High detail. And I think, let's see, what are some other things that we can tweak? We probably actually want more subdivisions on these antennas. And we want those to be smooth shaded as well. Need to fix the smooth shading on those drive panels too. Okay, so now we're just kind of doing little piddly stuff, but I'm kind of enjoying how this is coming together, so I'm going to keep going. And the panel parts, auto smooth angle needs to, oh, that's interesting. It's small enough that it actually needs to be smaller, more like 20. Yep. Sweet, but the smoothing on this needs to be more. I also want to add need to add like some kind of cutout or mounts for these, and I think I have a part for that, so we should try to add one of those in. That looks cool. I need to learn though how to not settle for how things look and try to keep pushing myself to make them look better. We should see, I think it's possible that the paint for this thing is still working, so maybe we might be able to get a nice render out of it at the end here. Okay, where's the antenna? Oh yeah, there's nothing there for smoothing, which makes sense. So these definitely can be narrower too. See, that's that same sort of thing where when it's and red. Yeah. So let's just add in a factor here. Red fact equals 1. So fact. And this we can make even smaller because these are supposed to be antennas, so it can be, I bet it can be 0.6. And so that's probably the only place where those are used. Yeah. Yeah, because the 8 centimeter radius, that's pretty thick. Yeah. Yeah. Yeah, that's looking pretty good. Something interesting to note here, you can see how the shading is kind of busted on these. And that's just kind of due to how normal smoothing works. So the way around that is to like slice it up and put it back together. So actually, as long as I'm thinking of it, let's see if we can do that. So let's yeah. And see that looks somewhat better. And you know what? I think we can go even smaller with that fraction. Like I think we want to add a little bevel on here too. Yeah. Don't have to do that right now. 0.25 that's too thin. All right, let's turn back on that slicing and see how it looks. I will probably, well, actually, before we do that, let's see if we can add that detail in, as long as we're looking at stuff. So on the Ashinoko, just gonna load a Blender file just to see where I was at. So I did have cutters. I guess I just... Let me see, because there was in the needle, I've got like a radiator frame. So I'm thinking, I'm just gonna copy and paste this guy, and that'll get us basically where we want. Oh, that's for the rad high temp frame. That's this guy. Oh, nice. That's a shared one. Good, good, good. Okay. Okay. Yeah. Let's Yeah. This is good. This will be a quick one to add. So. Yeah, so we can just wing some of this. So width is going to be like 1/3 of a meter. Length is going to be nice. That's already imported. Okay, that's the length already. I think this is just used to make, this is used to make that hole. So we actually want just like something like 0.1 and XY. Yeah, this could really be written better, but we're just going to get something going and then I can refactor this later. Let's see, width, height, extra, thick. Okay. Now we just gotta attach this frame basically at the same location where the radiators are. if I remember how this works. So let's see here. And I have this offset. What is this offset nonsense? Oh, that's, yeah, don't have to worry about that. That's fine. So, right, and yeah, we can toss out this guy. All right, let's see what this does. Fingers crossed it'll just do what we want the first time. But maybe it won't. Okay, yeah, we need to make it bigger. Need to make it a lot wider. That looked like a lengthwise overlap. There we go. Does it? Is it in the right spot though? Where is it? Oh, okay. So my radiators are like pretty far inside. Okay, and this needs to be turned too. Yeah, what gives? That's weird. This might be a project for offline, kind of figuring out what's going on with this. But let me just see here if there's a... I guess, yeah, I guess what's going on is I'm not... Yeah, I'm not really putting these guys on the surface properly. Let's see here. I'm just trying to think if there's a quick way to get this going. Yeah, I think I'll save this for offline. But we're very close. Let's just turn back on the panel cutting and let that run and see if we have any issues and see how it looks. So using these mesh booleans to basically, I'm scaling up all of the oh, I need to actually, that's what I need to do. I need to actually need to do the panel cutting with these things. So I had stopped up here originally, but we need to do this. So okay, so this is called devices. Yeah. Okay. So we want to cut the fuselage panels with a device keys, which are device keys is k in parts if k dot starts with devices. And that, actually, let's change this to be device prefixes. I just learned about this behavior not too long ago of you can do starts with a tuple, and it'll be true if it starts with any of those things. So that's kind of a time saver. So let's see what this does. This is oh, actually it finished. Nice. Not bad. Not bad. We could probably increase the factor a little bit. Oops. Oh, and yeah, we actually want all the sensors now. So we want device prefixes plus sensor 2 and sensor 3, and we could, so the way this works is it scales up the part slightly and then does a diff kind of against everything, so we can actually probably increase that a little bit. So that was 1.02. It's not the smartest thing, and I think I can come up with something better now that works better with my new kind of constructive approach for greebling things. Whoops. Actually, wait. Oh, so those guys aren't watertight. That is silly. Oh, I bet I know what's going on there. Okay, we can fix this quick. So these long sensors, I think I left off some faces in them. Yeah. So we can do this. So if LOD is greater than to 0, point end is none, else point end. Anil, hello. Yes, so I am making a game. What I'm doing right now is I'm kind of making some high detail versions of the ships from my game. So my game has these kind of low detail retro style low poly models, and I am writing some Python code to automatically add, well, not automatically, but programmatically add a lot of detail, 3D mesh detail to to those models for the purposes of kind of rendering higher detail stuff in Blender to make cool images or screenshots or whatever. Let me see if my ships run right now so I can show you what things look like. Nope. A few things are broken right now. Let me see if I can find some screenshots. So so for example, this is what this particular ship looks like in the game. So it's kind of a low detail, flat shaded, low poly model. Here it is in flight. Oh, that's not an actual movie. Yeah, so let's see here. It's probably a longer one. Yeah, so that's kind of what it looks like in the game, and I'm making a higher detail version of it. So this should fix that. Whoops, this should fix that cutting issue. Whoops. Solid. That actually isn't VY. That's odd. Interesting. Is the game live currently? No, it's kind of a hobby project. So I'm hoping maybe to have a demo or something sometime this year. Oh, there's the problem. Extra commas. I'm hoping to have a demo sometime, maybe like the end of the year. But it's mainly just something that I do for fun. So I'm a software engineer by trade, and I like programming. So this is kind of like my hobby project. And it's fun to share on social media. Okay, so here we go. So yeah, here we can see the cutouts. That looks pretty good. You get these sharp edges on things, which is like not ideal, but it looks okay. Yeah, that works. And let's look at the full thing now. So we'll get rid of the debug exit and this stuff, let it crank. Yeah, nice. So yeah, we definitely need some detail here. But overall, this looks pretty good. And I'm confident I can come up with some better ways to solve these booleans or do different panel agreeable. So, and Neil says, I'm a master's in computers application students. I want to try to make games. Looks fun. Yeah, so I would highly recommend it. When I was a kid, I actually learned how to. I kind of got into programming because I wanted to make games, and then I kind of learned about how the game industry works and how it's kind of exploitative, and I didn't want a job that stressed me out. So I do other stuff for work. So I work in machine learning and computer vision and things like that, kind of as a software research engineer. But I learned a lot about 3D stuff in my job, and I also use Python. And there's a lot of really good tools that you can use for making games using Python and things. So that's kind of what I'm doing. The game engine that I use, Panda 3D, it works in Python. There's some quirks to it, but it is pretty well documented. And I don't know how much you know about Blender, but Blender is actually completely scriptable with Python. So if you know Python, and I would recommend anybody to learn Python because I think it's one of the best programming languages that there is. You can script out all kinds of stuff with Blender. Yeah, okay, so this is looking pretty good, and overall it just seems so much more solid than I remember it seeming when I was working on this a while back. So I think we're in a good spot. So here you can kind of see the low detail version. Here's the high detail version. Lots of extra greebles and details. Dast we try to generate it and run the paint? Let's actually try it once. And I'll turn off the panel diffs. So hey Marcus. So Marcus asked, do you use a Pygame library for the engine? No. So I actually am using a engine called Panda 3D. And Panda 3D is kind of an interesting engine. It was actually developed by Disney, and Carnegie Mellon University sort of took it over. So it was actually originally used for this Pirates of the Caribbean RPG MMO that was made a long time ago. And it's there's some quirks and bugs, but it's actually really well documented. And it also is the engine itself is written in C++, and Python is kind of like a thin wrapper over it, so it works really well. And also there's some good tutorials. There's a guy named David Lettier, who has a kind of a article series called 3D Game Shaders for Beginners that's on GitHub, and it uses Panda 3D. And I would highly recommend that if you're interested in this stuff. So I don't think the game will run right now, unfortunately, because I've broken some things. Let's see here. Yeah. I've broken some things. I did a big refactoring this weekend, so it doesn't run right now. But yeah, I would check it out if you're interested. It's maybe a little bit lower level than some other Python game engines, so I like that about it. So Anil says, funny, I largely got into programming because my laptop had a pirated copy of Windows 7 that wouldn't let me get security updates. Now I'm deep in Linux admin, Docker, and stuff. That's interesting. So I kind of maybe was a little bit the opposite way. So I always used old hardware, and I was on Windows, and I actually used DOS as a kid. So a lot of what I learned about Linux I learned in college, and then on the job. So my first couple of years of my work, it was back in like 2012. We were doing big data stuff. You don't hear too much about big data anymore, but we were doing big data stuff, and that involved deploying a lot of these different big data frameworks on Linux. So that's kind of where I learned more about Linux. And I used to use Docker a lot too, for deploying some, not deploying, but like running some machine learning stuff. And I actually haven't had to use Docker now for a couple of years, and I'm sort of pleased about that because I'm not the biggest fan of Docker, but it's definitely a tool for a certain job. So I think that actually exported. Let me see. Let me just run that again. So this is just exporting stuff in a certain form, and then yeah, okay, so that did export. Let's see if it loads in. And we can take a look at it in the lineup if it does. I think it should. Nope. No paint. So Paint is the system that I built for putting Blender procedural materials on things. To comment out all of this crap. For a few months I was really working heavily on game development, and then I'm pivoting back over into the high detail stuff a little bit because there's kind of a milestone that I want to get to. With it, as far as being able to make some things. There it is. Nice. Okay, now the question is, does this stuff have materials? It does. Except for the radiators. So it looks like the radiators aren't quite working, but let's just take a look at it. Nice. Okay. It's looking something like I would want it to look like. We can turn this down. Let's see here. 0.5 and 1, and put the radiator material on it. And let's just tweak the colors a little bit and then get a nice screenshot of it. So I like to keep what I call a visual work log of my project, and it's nice to kind of have a record of the things that you've worked on to look back on. So I try pretty much every day to come up with some kind of visual artifact to so I have something to show for my work. I can actually desaturate both of these a little bit. And let's see. This I can two, one, and actually, let me just one more tweak here. So the edge, this edge color is kind of obnoxiously bright. This is the fun part after all of the programming to kind of tweak things and get to be a little bit more artistic with it. All right, well, that's not looking too bad. And in the lineup, it's comparing well to some newer designs, I think. Let me just tweak this a little bit so we get a little bit less less noise here. And I'm going to save a viewport screenshot. Let's see here. Render, put this at 56. That looks cool. Let's see what's a good view to get a little shine off of it. Actually, bump the min temperature on this guy up too as well, so we get a little bit more play out of that. It's pretty cool. All right. So what kind of game is it, Anil? Yeah. So it's actually a space combat game. It is kind of like a space simulation game. So you're flying your ship. It's kind of like if you've heard of games like maybe like Elite Dangerous or Star Citizen, like that. It sounds goofy to compare it to Star Citizen, but there was a lot of like space combat games in the late 90s, early 2000s, and that's kind of what my inspiration is for this. So that's the kind of game I'm making. Whoops. Keep knocking my mouse here. All right. And I think that about does it. So I'm going to call it good for tonight. Thanks everybody for watching and hanging out. It's really fun to do some work when other people are watching and have something to talk about. If you're interested in this project, I have a lot of other videos on my channel. There's live streams doing programming stuff, including more game development stuff as opposed to like this more like Blender-y 3D modeling type stuff. I also have a lot of videos and shorts just of the game, so if you're interested in what it looks like, make sure to check some of those out. I'm gonna take a screenshot here, and then I'm gonna call it good for tonight. Thanks again, and have a good evening.